In this video, we will be discussing partial fractions, which is another method of finding inverse Laplace transform of a little bit complex functions. Welcome to Enlightened AF YouTube channel. If you are new in this channel, remember to hit the subscribe button down below before we get started. By the way, subscribing to our YouTube channel is entirely free. I have a brief description of what is partial fraction and how partial fractions are used to find the inverse Laplace transform. Basically, partial fraction is a method of reducing complex rational functions into simpler functions. I'm using the term complex. They are a little bit difficult. They are not like what you are using previously in finding the inverse transformation. They are not directly from the table. Rational, it is a ratio of two functions. For example, we could say, let me use this space here. I have limited space. For example, we could say s plus 2, s squared plus 3s plus 4. It's rational because it's a ratio of two functions. That's why I'm using the term rational fraction. So we are going to reduce this complex function into a smaller function called partial fraction. We are going to make it smaller. This one is going to give us several smaller functions called partial fractions. And partial fractions are mostly used in finding the inverse Laplace transform, and they are also used in integration. Now, there are a few steps of getting the partial fraction, or there are a few steps of partial fraction reduction or partial fraction decomposition. The first thing is to check whether the degree of the denominator is bigger than the degree of the numerator. This is a degree. The highest power of the variable s is the degree. Here, the degree is 2. Here, the degree is 1. So this rational function is proper. This rational function is proper, and therefore we can go ahead and apply the partial fraction decomposition method. If the rational function is improper, then you have to make it proper by long division method. Suppose we had something like this. Suppose we had s cubed plus 4s squared minus 3s plus 4 over s squared plus 2s minus 6. Here, the degree of the denominator is less than the degree of the numerator. In that case, the rational function is improper, and we have to make it proper by applying the long division method. Fortunately for most of our questions in the exam, you will never encounter a situation where the function is improper. We don't have to bother knowing all this, how to use the long division method. The second thing is to factorize the denominator. Factorize the denominator. The third thing is identify the type of factors in the denominator. You have to factorize the denominator, and you have to identify the type of factors in the denominator. Step 4 is finally to find the partial fractions, or to get the partial fraction decomposition of the rational function. And when getting the partial fractions, depending on the type of factors in our step 3, there will be 4 cases of partial fraction decomposition. But we're only going to discuss 3 because the fourth one is not common at all, and therefore it will not really affect us much. Is someone cutting grass over the other side of the fence. The machine is making a little bit of noise. I think I might have to stop a little bit. But before that, let me explain the three cases. Suppose we factorize this denominator and we got maybe something like s minus 2, s plus 1. This is case 1. We have benmtrainingservices, meaning they are different from each other. Benmtrainingservices, they are different. Linear, the highest power here is 1. If the highest power is 1, then the factors are linear. So if you have linear distinct factors, partial fraction decomposition will take this form. A over s minus a. In case 2, we have repeated linear factor. Suppose this factor here is repeated. It is squared. That's what we mean when we say repeated. It is probably squared or to power of 3. It will take the unsquared factor or the unrepeated factor, it will still take this form, but the factor that is squared or repeated will take this form. In case 3, it is where we have irreducible quadratic factor. Suppose we realize it's not possible to factorize. It's not possible to factorize no matter what we do. Suppose we have something of the sort, maybe s squared plus 2. Now it's quite quadratic. Quadratic because the highest power is 2. If you have an expression and the highest power or the degree is 2, that expression is quadratic in nature. But if it's not possible to factor out, it is called irreducible quadratic factor. I should have used that one here. Let me include it. Irreducible quadratic factor, meaning it is not possible to factorize. Then it falls under case 3. And the linear and the partial fraction takes this form. It takes this form. So basically, those are the 3 types of factors that you encounter, but there are 4 of them. I'll do examples from past paper, if I could get everything from past paper, of these 3 cases. Of case 1, case 2, and case 3. Let me pause the video for a little while as I wait for the noise to reduce. The noise have now reduced. I hope I'll be able to finish my first example before the person who was cutting grass resumes his work. It is on the other side of fence. This school borders another school, primary school, so it's over the other side. There's nothing I can do. Then I'll try to quickly go through this example. Now, we said we have 4 steps. The first step is check whether the rational function is proper. Here you can see the highest power is 2, on the denominator is quadratic, on the numerator it is linear. So the power of the degree of denominator is higher than the degree of numerator. So the rational function is proper. Of course you don't have to say that, but I will say it here for purposes of your own understanding and revision. So rational function is proper. In my initial explanation, I was calling this rational fraction. It's not supposed to be rational fraction, but it is a rational function. I think I made a mistake in my sentence, and I was not quick to notice that mistake. But it is a rational function because it's a ratio of 2 functions. In fact, we usually call it rational polynomial function because these 2 are polynomials. But let us forget about that. Step 2 is step 1, step 2. Maybe I should say here step 1, just for purposes of us being able to follow through. Step 1, rational function is proper. Step 2 is 1. Step 1. Step 2. Let us factorize the denominator. Step 2 is factorize the denominator. What is the denominator? We have s squared plus 5s plus 4. Let us factorize. What is the product? Product is 4 times 1. Product is 4. What is the sum? Sum is 5. I hope you can remember this is in your earlier years of study. So we need two numbers. If we multiply them, they give us 4. They give us 4. If we add them, they give us 5. What are the numbers? To me, the numbers appear to be 1 and 4. 1 and 4. So you can now write this expression as s squared plus s plus 4s plus 4. Let us factor out. Okay, if we factor out here s, it will be s plus 1 plus, if we factor out here 4, it will be s plus 1. So now the expression is s plus 4. Let me start with the smaller one. But you can start with either s plus 1 into bracket s plus 4. So I'm rewriting the same problem but using the factorized denominator, which is s plus 1 over s plus 2. S plus 2. We have already factorized out, so we can identify the type of factors. Check. This is s to the power 1, it is linear. Here is s to the power 1, it is linear. We have two distinct linear factors. We have two distinct linear factors. We are now ready for step 4. Step 4. Step 4 is to decide is this case 1, case 2 or case 3. This is case 1. This is case 1. Of course, you don't have to say all this stuff in the exam. I'm only trying to communicate to you so that you can understand. See, mathematics is a language. You have to communicate. If I just drop figures, numbers, values, expression here, it will be very hard for you to follow through. The same case with on your paper. If you just drop numbers and figures, it becomes a little bit harder for examiner to go through your work. But when you mention just a sentence, it becomes much easier to follow through. This is case 1. Partial fraction take the form. We said in this case, under case 1, there will be of the form a over s plus a. A is a constant and a small is a constant. So you have s plus 2 over s plus 1, s plus 2. That's what we have. Now let us write it in partial fraction. We take the first factor, which is s plus 1. It is linear and is distinct from this one. So we take the first factor. We say it is a constant a over the first factor, s plus 1. S plus 1. You see, this is just a general formula. We didn't know this a small will be 1. That's why we are just using a general formula. But a is yet to be determined. We have to determine it. Plus, because there are 2, we must add the second factor. Plus, b, I've used symbol a. Now we use symbol B. You could have decided to use symbol maybe P and here use symbol Q. Or you could have decided here to use symbol W and here symbol S, whichever you want to use. Exactly. Divided by the second factor, which is S plus 2. We can also say, I'm only saying this for purpose of your understanding. You don't have to say it. A and B are constant coefficients to be determined. They are constant coefficients to be determined. How do we determine them? Multiply both sides by the denominator. So you have S plus 2 over, you have S plus 2 over, is S plus 1, S plus 1, why did I get 1? Okay, it was S plus 1, S plus 4. Why did I get the 2? This 4. Where else? This 4. I don't know what was in my mind when I decided to change the 4 to 2. S plus 2, S plus 4 is equal to A S plus 1 plus B S plus 4. What you are going to do, you are going to multiply both sides with the denominator. What is the denominator? S plus 1, S plus 4 times S plus 1, S plus 4. Multiply with S plus 1, S plus 4. This is the first example. I'll do a lot of writing and a lot of explanation, but in the next videos, I'll be doing less writing because I would assume you have already gone through the first video and understood the concept. So I'll be skipping a bit of my steps. The same case in your exam, you don't write so much because you only have 3 hours. If now you have to do that, the whole of this will cancel with this. So we have S plus 2 is equal to, let us open the bracket. When multiplying this S plus A over S plus 1, this you can't work with that. So you only have, if you now open the bracket, you only have A in the bracket S plus 4 plus this plus. In multiplying the order of these with this, the S plus 4 and the S plus 4 will cancel out, meaning we'll be left with what? Meaning we'll be left with, because this and this have cancelled, we'll be left with S plus 1. So it will be plus B S plus 1. So it is AS plus A, AS plus A. If you open the bracket, it is AS plus 4A plus BS plus B. Let us have the factors with S together. So it will be S, not the factors but the terms with S. The terms with S together, it will be S, yeah. The factors it will be A plus factor of S it will be B plus the constant terms 4A plus B. So now it becomes S plus 2 is equal to all of this, equating equating the coefficients of s and the constant on both sides of the equation. On both sides of the equation. So equate the coefficient of s and the constant on both sides of the equation. This is s. It will be equated with the counterpart on the other side, s a plus b. So equating the coefficients, so this and this will cancel out. S and s will cancel out. Here we have 1, here we have 1. So it will be 1 is equal to a plus b. If we equate the coefficient, this is 2. 2 is equal to equate. No, if you equate the constant here is 2, equate with the constant over the other side. Therefore, 4a plus b. We are calling them the constants because they are not being accompanied by s. They are just around. They are Root's values. Now let us, we can solve this. Which method do you like most? But it appears elimination is the simplest. I don't know whether you should subtract or add, but I think subtraction is the best. I wish I could rewrite them. Let me write them down here. I say it is 4a plus b is equal to 2. A plus b is equal to 1. And we do a subtraction. 4a minus a, 3a. b minus b, 0. 2 minus 1, 1. Therefore, we can say 3a is equal to 1, a is equal to a third. If we know that, then we can say a third using this expression plus b is equal to 1. Therefore, b is equal to 1 minus a third. B is equal to 2 thirds or 2 over 3. So this is what we need. We have determined the value of the constant coefficient. Now we go back. Our initial expression was, what is our A? A third. It was a third s plus 1 plus 2 third s plus 4. It was like that. If you want, you could say it is 1 over 3 or simply 1 over 3 s plus 1 plus 2 over 3 s plus 4. You can write it like that. There is no problem. I forgot to mention this, an extra step. Step 5. Step 5 is determine inverse Laplace transform. Determine the inverse Laplace transform. So this is equal to this. So I'll say inverse Laplace transform of s plus 2 over s plus 1 s plus 4 is simply the same as determining the inverse Laplace transform of 1 over 3 s plus 1 plus 2 over 3 s plus 4. So now we could say is this inverse Laplace transform of 1 over 3 s plus 1. So have each one of them separately. Inverse Laplace transform of 2 over 3 s plus 4. We make this one to cover the whole thing. See, here, the constant are that and the constant 2-that. We can get them outside the inverse Laplace transform symbol. You are getting inverse Laplace transform of inverse Laplace transform of 1 over s plus 1 plus 2-that inverse Laplace transform of 1 over s plus 4. See, these are much easier to deal with because we can directly identify them from the table. That's why that's the essence of partial fraction decomposition. It makes the fraction look smaller and therefore easier to handle. Because this one we can directly find them from the table. This will be, if you check from the table, it will be inverse Laplace transform as s plus 1. Notice this is inverse Laplace transform of 1 over s plus a, which will give us exponential at, but a is exponential negative at, but a is 1, so it will be exponential negative t plus 2 over 3. Notice again this one is of the form 1 over s plus a, which will give us exponential negative 4 t. So we are done. We have determined the Laplace transform. We have determined the inverse Laplace transform of the function. Something I didn't say in the first video of inverse Laplace transform. Whenever you are given a function to determine its inverse Laplace transform, you must always try to factor out first. If it's not factorizable, it will be a different case. If it's possible to factor out, it will either be case 1 or case 2. So always first attempt to factor out your problem. So continue watching more videos on the edit screen template shown.